professor at Stanford, won all the awards like career awards, Samsung AI researcher, Sloan Fellow, and so forth. And she's been doing really interesting work at the intersection of LLMs and NLP and how it impacts like societies. So excited to hear from her.
Thank you. Hello, everyone. I'm Diyi. I'm actually very excited to be here to share with some of the very different type of work today. And when I look at the title, just like Jason mentioned in his talk, emerging generalization, the definition is something around applied research, something different, something that's not very well defined. And this is actually a really good capture of my own research because I care a lot about social factors. And I'm going to share you a few highlights today. So let's get started. We have seen a lot of evaluation and generation efforts in large language models these days, specifically around performance, efficiency on benchmarks. And as I mentioned, I would like to share a very different perspective that my lab has been working on to better understand the large language model generalization, specifically from the component of people. So how can we come up with a mathematical formulation for people? This is going to be very, very challenging. Why do I care about this? Because when we interact with large language models, when we use them for real-world applications, people actually bring in their culture and norms into their interaction with large language models. Focusing only on the technical aspects without considering the social aspects could result in inappropriate response and limit the usefulness of large language models in real-world applications. I want to give you two quick examples of such concerns, and I want to give a content warning as well. So the first one is actually about culture and social biases. So we know that models are doing amazingly well on math and coding, reasoning, etc. Why don't we just ask it a specific question, like what I have on the screen? You can read it. It's about having or going with friends to drink. And what if we give these two models like what we have today, GPT-4? Or maybe we can give it to even Arabic-specific large language models. So we ask them to complete culturally evoking prompts that are written in Arabic. You can also see the translation here. Very interestingly, if you read this kind of output, very naturally you'll realize that large language models actually generate entities that fits very well in a Western culture without being very culturally relevant to the specific question here. In a slightly different context, let's look at the language, or I work on English NLP most of the time. We see that there has been a lot of issues when models being applied to what we call low-resource language and dialects. Specifically, some of the news articles already highlighted those. And in my own research, and also I covered this last year at Simmons for a different workshop, where we talk about low-resource dialects. For a language as high resource as English, we call it standard market English. That's what we have focused on in most of our evaluation. But if we change the question from standard market English into Chicano English, Apache, African American Vernacular English, Indian English, Singapore English, we saw that the performance actually drops significantly. This is what we mean by generalization. That is, when we apply the two even within the same model family, but the grammar, the lexicon, the syntax might be different. And I'm not even talking about pronunciations or accent here. And you see this kind of very interesting performance disparity happening in those contexts. So what I want to mention today is that generalization without considering this kind of social aspects could result in a proper response and limit the potential use of large language models in real-world applications. And things that my lab has been working on is to think about how we can actually integrate social factors and social awareness into large language model evaluation. The goal here is that we can discover new problems, find something that's really hard to formulate, challenges, and even solutions that can, in the end, help create more trustworthy and also useful large language model systems. So related to large language model generalization, I want to share three perspectives here, from assessment perspective, from adaptation, and also application. So first, I want to share some kind of dynamic evaluation protocol that we recently introduced. The key idea is how to provide a very reliable evaluation of large language models on many types of reasoning tasks, not only just for math, but also for social reasoning. And then I think we are going to explore how to adapt the large language models to be socially generalizable by building culturally aware language technologies with an online community-driven knowledge base. And in the end, I think I'm going to show you some very cool applications. That is how we can actually customize large language models for social skill training in a variety of social contexts. So I really want to make this more interactive. So if you have questions, feel free to stop me anytime. Let's look at the first one, dynamic evaluation of large language models. So why do we even need this? I think one of the potential concerns with evaluation is that models have been trained with a lot of data on the internet. They might memorize training data. They might memorize evaluation data. As a result, it's really kind of unclear whether we are obtaining a very clean evaluation of the model performance. So on this screen, this is about the cutoff date and the model performance. There are also this kind of A and B curves where A is B cannot be used to infer B is A examples that we see all the time about this kind of potential issue of data contamination. Related to this, we also kind of explored that how models may even memorize different type of data. So a recent work from our group showed that actually those bigger models tend to memorize more, and even when they see the sequence a few times. So in this specific study, we actually introduced a relative causal kind of setup where we get the model from a certain checkpoint, and then we train it for certain steps. In the parallel setting, we give it a specific sequence with many times that we wanted to memorize. And then we can see that how those two different checkpoints differs. So you see this kind of very empirical evidence that memorization, data contamination might be happening with our existing evaluation. To summarize a lot of the challenges that we face with large language model evaluation, I think in addition to models memorize the evaluation and the training data, current evaluations on benchmarks are also really hard to be updated. Especially when we have more recent and more advanced large language models, it's a little bit unclear how they can co-evolve together. So the question here is, does those numbers on all the leaderboard we see reflect their capabilities or abilities? The answer is always unclear because we don't know how well they perform when it comes to specific applications. So here, we are arguing that we actually need a more dynamic evaluation. In this way, we will have less concern of data contamination. We can generate evaluation data with controlled complexity and also make it adaptive to large language model evolving capabilities. I'm going to show you what I mean by this kind of dynamic evaluation here. Specifically, I want to introduce this concept called adaptive reasoning graph. Again, reasoning is a very broad word, and here we basically mean how the model carry out or how they might take a specific procedure to carry out the solution process. And it has 3 steps here. So think about we have a data point from an existing benchmark. And what we are going to do is that we'll first induce that data point into a graph. And then based on that graph, we are going to do some kind of perturbation on the graph. When you have a new graph, we can then convert it back into a text description. This is what we call new sample generation. You can do this with graph-to-text decoding, and you can also add some verification procedure. Let me go through how this actually works. So let's just take an example from a math reasoning data set, GMS-AK here. You have a question, you have an answer. This is what we have to use or to evaluate the models. we'll first perform this kind of graph induction. That is, we are going to use a graph structure to represent this specific text description. Now we have a relative intermediate representation. In step 2, what we are going to do is we are going to do manipulation over this graph. We can manipulate the numerical complexity. We can make the graph wider, deeper. You can actually do a lot of perturbation here. Of course, when you do this kind of perturbation, you need to find a mechanism to ensure that there is a way to derive the new label. In step 3, once we have this kind of augmented or perturbed graph, this is a new graph, we are going to perform graph-to-text conversion so that we can find a text description of what's there for this new graph. You can even introduce some kind of data verification mechanism so that, let's say, this might be an external large language model agent that write code to solve these problems, and then you have some kind of specific answer. You can then compare that answer with the original label you derive when producing the graph. And in this way, we basically generate different data points for the same given data point with controlled complexity. Any questions until this point? Okay, all good. I'm going to show you how this actually works. And I use a math reasoning as one example. We actually also did it for spatial reasoning, social reasoning, and many other different type of tasks. Yes?
The numbers that are going to be in this example, so are those already predetermined or somebody inputs them? Like how are these new, like how is the perturbation done to make sure that the input and the output are actually correct?
Yes. So let's say for this specific instance, you have this kind of original graph you derive from the text descriptions. Now we are going to define a kind of like function. This function is going to control several aspects or properties of the graph: numerical complexity, depth, like width here. So for this kind of number change, you can actually just do random sampling there. So like you can random sample a number with a certain range, and that's up to how you set up your constraint function. And then you can easily change like 2 to a number, I don't know, like 103 or 174, et cetera, et cetera. So this is how you deal with numerical complexity. With the graph depths, this is also something you can just like introduce. Because those are somewhat a computational graph, you can actually perform just like derivation on top of it to calculate the number.
To understand the setting like more clearly here. So on the left, what you have is like some examples that you know is correct.
Yes.
And therefore, we know that the graph is correct, that if I sample different numbers and push through this graph, the answer would be correct.
Yeah, so let me clarify. So this graph is actually converted from an original data point. This is like something probably in the evaluation set. So the answer is already correct. Otherwise, we won't be able to have ground truth. So we simply just do this conversion. There's nothing involved with like hallucination or whatever. And at this step, when you do this kind of like give it a new labels, give it a different depths, etc. We also perform like calculation on the graph to derive a new label. Yeah, we have some kind of human validation to check whether the label makes sense, and the accuracy with human annotation agreement is something like above 95. Maybe there. And
yeah, so general reasoning does not have these simple graphs. So do you have examples?
Yes. Yes, so that's a great question. This is why this kind of like internal graph is actually really hard to define. I can show you a few examples, especially for social stuff. So this is what we can derive for social situations. Another data set or another context we look at is for, let's say, social bias. Those kind of social bias usually have questions like this. You have a very kind of scenario-like description, and you have questions you are going to ask models. This is actually how we assess biases in large language models. So you have this kind of description. Then what we need is that if we need to convert this into a graph, we actually need to find what is node, what is relation, and what are some operations on top of that. So for this kind of social situation, the node is going to be all the like nouns or like the entities there. And then the relation is going to be the specific relation among those people. So the specific graph we constructed on the left. So you can see that we basically have this kind of weakly related kind of graph where the node is going to be specific people, and then there are relations, etc.
But now you're going to use this graph to generate a new question?
Yes. We will do perturbation on top of this graph so that you have a new graph.
Okay. So we've done things like this too. The trouble with these is that now they have your recipe for doing this, and they can just find it. Right?
Yes, I will show you some results there. Yeah, I will show you some results. That's a really good point. Okay, let's continue. So first, if I just use this on like math evaluation, so this is on math reasoning, data set called JMSAK. What you see is that, so here I show different complexity perturbation. So you either do numerical complexity increase, or you do make it wider, make it deeper. The original one is always the first left. And as you can see that model performance actually dropped significantly across different type of perturbations here. Like something that we take as 0.8 probably drops to something like 0.4 in the end for different type of models. We have more kind of results on this just to give you a specific highlight. For social reasoning, yeah.
If they fine-tune on your synthetic data, they'll do well.
Okay, yes, I have the results later. Can I go? Maybe we can talk about this first. So yes, you're right. So once you have a recipe to kind of create this kind of data, what you could do is that you can also do fine-tuning with this synthetic data. One thing I want to kind of highlight here is that it's true that if you have a mechanism to kind of introduce more ablation data, it will also can be used to increase model performance, since this is a way to create argument or synthetic data. One thing I didn't have it here on this specific page, but in the paper, we still observe like certain kind of disparity between what you can have. Like still after fine tuning, you observe like slightly decrease as well. Yeah. But this is a good way to kind of mitigate and also speak to the power of synthetic data, especially by providing like lots of examples. You already see these results, but similarly on social reasoning. So this is a task where we used to mirror like bias against the protected groups. You saw that it also kind of drops significantly here. And the data set has two different types of settings where you can look at a very ambiguity context where the model should answer, I don't know, or there are very clear contexts where there is a specific answer. We observe a consistent trend. And also, if you just quantify model biases, after this kind of perturbation, the model biases increase dramatically. So what we observe is basically like these social reasoning capabilities drop significantly with increased complexity. And also another thing I want to highlight, you can read it more in the paper, is that models are also very sensitive when you try to do this kind of social reasoning ablation. Like most cases, they will answer with, I don't know, like, etc. So to kind of summarize the first part, hopefully I share with you this kind of dynamic evaluation protocol and provide insights that this is actually a very interesting way of doing performance assessment. Social understanding capabilities actually drop significantly, and this is an area where models are oversensitive and in most scenarios reject to answer any specific questions. Yes, so for each of the settings, so we have like math, we have social and spatial and others. For each domain, you basically need to define what do you mean by node, what do you mean by constraint, what's edge, what's the relation, etc. So for each domain, we actually sort of have like a graph definition. And yeah, perturbation is, so if you need to do like perturbation for math, then you know that it's going to be numerical complexity, etc., etc. If you're going to do with social, then those would be like the polarity with specific entity. Like previously, this person was feeling positive or feeling happy, but now you can you can manipulate the node more from an emotion perspective. So we define specific properties.
So it's defined by you.
Yeah, but it's a large collection. Yeah.
Maybe perturbing beyond like new you mentioned depth and width of the graph, but like new operations, or even maybe changing like in a victim play setting to just go beyond that domain, because you're constrained to a domain, and maybe that addresses the problem of fine tuning. Like if you can actually come up with proposals of new domains or something.
Yes, this is a great question. First, if you do like a very aggressive ablation, you lose the capability to find the ground truth label to some extent. So the reason why we are constrained is because we still want to maintain the procedure to get a label. However, I think what you mentioned can be useful if you just use them as data without the kind of like ground truth labels. Those synthetic data with relative noisy kind of labels might also help from a synthetic data training perspective. Okay.
Are you worried that you might end up in a situation where you get sort of something that looks like an adversarial example? Like you're looking for harder and harder examples. You get like less salient, but obviously stuff that the LLM fails on. Like how do you want to balance like kind of the salience of the questions that you have versus the difficulty?
Yeah, that's a great question. So I think there is a tendency that if you make the question harder and harder, like from a kind of very intuitive perspective, those questions become really just like which like has a lot of descriptors and like really hard to see in real world, which means that they are really like mechanical, does not make any sense. So it's possible. With the qualitative examples we have, actually what we see is it reveal more of the like maybe more like the first level or surface level errors. Like for example, when it comes to math, once you perturb the numerical complexity, then you start to see this kind of 3 digits times 3 digits and result in a wrong calculation. So it's not like models fail with this kind of very complicated parsing of the sentence. It fail with this kind of very meta capabilities that models demonstrate. So we do have a few examples there. But it's true, especially when we manipulate with some kind of spatial reasoning examples, we basically create a really kind of complicated and even nonsense, but still logically meaningful examples. Okay, I'm going to maybe last question.
Yeah, I was just curious about like, so a lot of these like new benchmarks comes out, but at the end, like, does the ranking between the models change ever from the simpler to the harder benchmark, or you know?
Yes, that's a great question. So what we found is that the ranking actually are somewhat consistent with the absolute number can present it to you. So you can see some of those, especially for math data sets. So all the lines actually you rarely see that they really like cross each other. I mean, there are a few instances, especially when the questions get super complicated. But like in the beginning, there aren't many kind of such scenarios, especially from like a math reasoning perspective. However, that's not true when it comes to more subjective task. So with subjective task, there is one figure that I didn't show here. The animation is not working, but like especially for like we also quantify refusal rate. That is, when you perturb this kind of social situations, what models always output, I don't know. Actually, that one, I think like bigger models are more kind of RHF aligned. So they always just refuse to answer questions, especially with protected groups. So I think like pairwise, relation-wise, that one actually stands, even if you do this kind of perturbation for most of the data sets. Okay, I'm going to continue since I have several interesting work later. The second part I want to kind of talk about is since I care about social factors. And what I found out is that it's really, really hard to provide a computational framework to talk about something like culture. We all think culture is very different. It's very important and different, but it's really hard to quantify it. I think I already shared with you that this is almost everywhere. And here, our definition for culture is a knowledge shared by a group of people about their joint beliefs, practice, and behaviors. And to give you some kind of quick highlights of why this has connections with large language models, I want to show you a very interesting query. So many of us, when we attend a conference, especially outside of the US, usually we ask a question, where are you from? At least this is the question I asked this morning while we were in coffee break outside. You ask, where are you from? And here, I ask it to AI assistant. And I force it to take an answer here. I am from country X. You can then enumerate a country with all the country names we have. And this is what's going to happen. So if we use a reward model, let's see here, I actually use a starting 7B reward model produced at Berkeley to kind of assess model's response to my previous question. So the only changing variable is country here. And what you see from this kind of reward map when map it to a global space is reward model mostly prefer US, Canada. So as you can see from the blue color here. And for other regions, this kind of reward model give very low reward, or in other words, they are biased against Central Africa, Russia, China, and the Middle East. So this is a very interesting observation. Remember here, I only ask a question that's very benign. Where are you from? We also ask many other kind of questions from global opinion and many other data sets. You see similar patterns in terms of how those reward models actually calibrate concepts related to culture, norm, value, et cetera, et cetera. So why does this matter to our current work? In addition to this, I also want to share you this kind of use case. We all like travel a lot. So let's say you want to plan a trip to Germany, and you ask a specific chatbot about, is it okay to smile to greet strangers on the street? The first response we got from model was actually, yes, it is okay to smile to people on the street in German as a friendly greeting. Anyone who disagree here? No? Why? Why?
People are a bit more, cold, I guess. This is not my experience in Germany.
Yes. So from a social perspective, actually expressing emotions in public space in Germany is actually not very often. So like being like a smile to people, this is actually viewed as a violation of this kind of privacy to some extent. So in general, you want a model to tell you something that's like, oh, it's less common for people to engage with strangers on the street. So this is a very interesting example, but it's also so nuanced and so subtle. You might be argued that models already see a lot of instances like this on the internet. Why are they still telling us one versus other? I think this is a really good question. We don't know. So if we want to kind of quantify this more computationally, we really need to give a definition to culture, or at least find a way to represent the culture. And then the other question is where to find it. We actually think about this from a knowledge-based perspective. I will finish this page. So we actually represent the culture from a structured knowledge-based perspective, where we define a lot of attributes to quantify a specific culture descriptor. So you will have specific culture group, context, goal, actor, recipient, relation, actor's behavior, recipient behavior, other descriptions, topic, agreement means that is this something that most people agree with, or like only a few people in certain regions agree with, et cetera, et cetera. So this is not a perfect description, but it's a practical, useful taxonomy to basically describe a lot of the culture phenomena we see.
I was surprised that the LLM got the question about German smiling wrong, which LLM was that, or maybe I should just ask, do the largest ones get it wrong?
Yeah, so that's a great question. So if you ask GPT-4 today, this is also one thing I want to mention. Like these days, whenever speakers show example on the slides, I think many of you probably are trying to try it with GPT-4 or ChatGPT on your laptop. I think it's very likely they are not going to work out. This is in earlier days when we started working on this, we observed this instance. But I will also show some results with GPT-4 so that you know, like from an aggregation perspective, how well it works.
Okay, yeah, the reason I thought GPT-4 would come like this is there must be tourist advice, and it knows about so many things that it has no right to know. Like if you ask it how to give, how you would advise an actor to read a sentence, it doesn't know how anything sounds, but somehow it knows how you should pronounce the sentence as an actor. So I guess the skeptical view is you don't need a structured knowledge base. You just need to, like when the models get bigger, it'll take care of everything.
Yes and no. So yes, I think when the model gets bigger, I think they are usually more capable with many stuff. No, because no on the side of like more like a non-tail cultural knowledge. So I will show some of the results later. But the other way is that whenever we are working on this kind of more like culturally aware language technologies, the goal is not only simply to improve model performance on some kind of downstream task, but also provide a way to kind of document the cultural knowledge from this kind of cartography perspective. So there is also this way of explanation, auditing, etc., etc. Okay, I will continue. So so now this you have somewhat.
Yeah, sorry. I think the question. I mean, of course, it's okay to smile at people in German streets.
Yes.
Don't necessarily listen to each other, not much, and it will vary across different places. It's also in the UK, like on the underground in London, people don't typically smile at each other, but in many towns or cities, it's an incredibly complex question. And of course, within any culture, there's a lot of forgiveness. I mean, do Americans stand out in every European country? Yes. Even though they look European. Are they aware of any of the norms they're infringing? No. Do mostly people accept that? Yeah, because it's part of culture to sort of say, well, of course, they don't understand.
Yes.
And so all of this is really quite complicated in terms of this second guessing of who it is and what they're doing and what the context is, right?
Yeah, I love your comment. I think this is why we are here for the emerging generalization workshop, because this is something that's really hard to define. And the reason is that culture and the norm is not like a binary label or concept. It's a spectrum. Some of the norms are things that you can put into law that's legally responsible. Some of the norms is like, it's great if you do it, but even if you don't do it, you won't be whatever. So it's a spectrum.
If you start behaving like an Italian in Italy, then they'll expect you to behave fully like an Italian. So you better be careful. So the notion of generalization becomes very complex across cultures because it's a shared agreement within the culture that this is how we behave. And someone not behaving like that is initially a clue to like, well, they're going to cross the street in different ways. You know, like an Italian driving along, seeing an American trying to cross the street, will expect them to cross the street in different ways than an Italian. So the problem is, I think that most of our notions of generalization have some underlying sense of truth. But when you're looking at the diversity of all humanity, truth is varying according to culture, but the knowledge of that variance is also embedded within those cultures. So, I mean, it is a really interesting example of generalization and what it means.
Yes. So I think I totally agree with you. So one thing we wanted to capture that is context. This is basically like where it happens. And then we also try to model the potential relation between the recipient and actor. And having said this, as I said, this is not going to be a perfect taxonomy, but we hope to use it to provide a somewhat extendable or interpretable kind of visualization of the culture description here. And it's going to be a spectrum. As you can see, the agreement level is not always very, very high among people. Some of those is very regional, some of them is very global. But bring it back to the context of large language models. If you want the models to give you trip advice or give you some kind of information about how you should behave in a foreign country, this knowledge actually becomes important for us to consider. So you still have to find a way, although in practice they may be very like really like contextual and also intertwined with like belief and forgiveness and other factors.
Right? Like you want the model to tell you that these are all the options, not to give you one filter bubble, like, oh, smile, don't smile. You actually want it to, based on context, like these are the different contexts, different norms, all the options. So yeah, so it should be.
In a way,
that's interesting. The problem is that's interesting. So, you know, the nuance of what's going on in different cultures is extraordinary. And I think the more you think about it, the more extraordinary it becomes. So, but I do think it's quite interesting, your point about trying to get it to itself belong to a different country. So, I mean, I think that's what you were doing, which is like, you can get it to form a character of one person from that, and then you can start exploring that nuance.
Yeah, I think this is great discussion. We can move some of those offline. I want to show you some of the results. It's actually very interesting. And also, my last part is going to be something super exciting that I hope it will be very relevant to many of us. So we found a way to kind of describe culture, this super subjective and contextualized concept. Very hard to kind of formulate that. And very interestingly, what we do is that we go to a lot of online communities, TikTok, Reddit, a lot of Twitter, etc. And then here, I just use TikTok as one example. People talk about culture difference, culture shock. And even just using TikTok for like 2 years of data, you can actually get a lot of comments. And what we then do is find all these kind of culturally relevant descriptions. So for example, this one's, I was traveling in Japan and I left the tip as thanks, but the owner returned it. You have a lot of those. And then what you can do is that you can use, at that time, Llama 2, and with a lot of in-context examples to convert this into the specific format in the cultural representation I just mentioned. And then we then did like human evaluation just to see like, oh, does that make sense? And does it faithfully convert it into this specific format? The overall accuracy between what human annotate and what the Llama 2 produce with in-context examples is something around 82%. So even after this, you get a lot of such cultural descriptors. I'm not going to go deep into how we condense them into a knowledge base, but then you can imagine there may be different instances about the same thing. There may be people who agree, who disagree, etc. So we did a lot of engineering efforts to cluster and reduce it into an easy-to-use knowledge base. So in the end, if we just look at TikTok, we actually got around 730 cultural groups for about 36 topics. And if you map it to the global map, just based on TikTok data, here's what you have. Very interestingly, they cover lots of aspects. Some of them is about social norms, some is about food and dining, and or family dynamics, communication language, etc., etc. It's actually very rich in terms of what you can actually have from this kind of online communities. I want to show you more examples, but like just to quickly look at some of the cards that we have from our knowledge base, we actually have very interesting behaviors. And the agreement here is what I mean by when we collect, let's see, 100 such instances for the same phenomena, you can then basically infer, do people think that this is true or no, etc. So then you basically calculate this kind of agreement score here. So now what you can do is that with this kind of knowledge base, if you want to increase cultural awareness here, we presented this knowledge base, and then you can do very grounded evaluation to kind of ask models like whether they know this kind of cultural knowledge. I will have 2 slides for this as well. And then you can have this relative more socially aware or culturally aware large language models, and you can use it for a lot of the downstream applications. One thing, the reason why I want to mention evaluation here is we all have the instance where if you just ask a model, is it common for X to do X, or is it a true, etc. There is always this kind of confirmation bias, or they will just answer A or B, but probably does not mean they are going to follow that in the actual scenario. So we want to kind of evaluate them in a very grounded setting. So what we do then is to generate a story snippet for each situation. So basically, let's see if our culture descriptor is no tipping in Japan, then we are going to convert it into a rich kind of story scenario where the answer needs to be somewhat related to the culture descriptor here. And then this is one type of answer the model could return. And then we are going to do entailment measurement. We are going to do a human evaluation to see whether the answer is appropriate. So this is a relative more grounded way of evaluation. Going to some of the quick evaluation of a large language model. So here, support means that how many instances of support we can find for those cultural knowledge. That is, are they very frequent, less frequent, etc. If you look at different model families here, this is for Llama 7B, 70B. This is for mixture family and GPT family. So very interestingly, I think first, they are all somewhat different, especially models like GPT-4 are definitely going to be better because of their size. And the other trend we observe is that especially for long tail cultural knowledge, there is slightly decrease. By slightly, I mean something like 20% here in terms of their overall performance. The other thing you can definitely do is that since now you have this kind of knowledge base, you can actually fine tune with our culture bank here. If you just compare like Llama and the mixture family, the vanilla version, and versus if you just take some portion of our data to do the fine tuning, you can actually increase the knowledge entailment, which is an automatic metric we use here. And more specifically, we generate around several hundred of such conversations and do this kind of human evaluation. So basically, we quantify the win rates here. And we also measure the tie rate. So as you can see, compared to GPT-4, our fine-tuned version actually can do very well, especially when they go to like this kind of culturally loading or heavy questions or prompts. And specifically, when it comes to downstream culture-related tasks like global opinion and also culture NLI, we saw that they also perform better.
Just a clarification. Originally, you described Culture Bank as a structured database, but you didn't mean it was SQL. It's still text, right?
Yes.
It's just that you've been systematic about populating it.
Yes. So you store them into this like a systematic way where you can do operations like, okay, finding all instances about Mexico social norms. So you can actually perform relational extraction there.
I had a quick question. The graph you showed for TikTok, your TikTok data, it looks qualitatively similar maybe to the graph you show with GPT. If I'm not mistaken, you're taking only English questions and then seeing what the culture shock they go to different countries. Like, is this really an accurate evaluation of low resource languages if you're not going to consider, like, you know, of course, like this is the very common use case where someone from a different country comes to the US experiences culture shock?
Yeah, great question. We haven't solved or we haven't integrated low resource language for this part yet. So right now, the culture bank is, as I mentioned, it's an English NLP effort to see, like, can we first like extract all this kind of cultural knowledge for English. For other languages, there are like bigger issues. First, not all languages have equal presence on internet. So even you take the same procedural, same method to scan the internet, we won't be able to find a lot of instances. Part of the reason is that many regions in the world, they even don't have like high-speed Wi-Fi to use network and many others. So right now, I think there is the very natural data scarcity issues. So especially when it comes to culture, you don't have a lot of those instances.
Yeah, I guess that's, sorry, that's what I'm asking. Like if you depend on internet data,
yeah.
How's this solvable?
Yes, so that's a great question. So the kind of efforts we are exploring right now is from a more like HCI perspective called a participatory design, or from a local community perspective. Imagine now you have a very nice, best practice of how to collect the culture knowledge, high quality culture knowledge. You share it with different local communities in different parts of the world. They contribute, small amount of such cultural descriptors, and that's basically going to be a very powerful way of doing that. So similar efforts, although this may seem like very ambitious, similar efforts do exist. So in terms of like audio data, there is this effort called the Common Voice, where volunteers from different regions actually contribute their data. And there are also similar efforts like data bank where people donate their data. So I think potentially to mitigate issues like this kind of online data repository, you probably need more this kind of local community-centered efforts.
Building on that question, it made me think of when you showed the acceptability for the appropriateness of different cultures in the map. For some reason, Chad was blue in the middle of Africa. Did you?
You mean fault line, like a cultural misalignment?
Yeah, with cultural misalignment, there was a good cultural alignment with
yes,
Chad,
yes.
I personally don't believe at all, and I'm suspecting. Have you looked into Chad? I mean, also the Antarctic. Everyone's like.
There is a very interesting explanation.
What the reason for that is, and is it associated with this data mismatch? Yeah.
Yes, there's a so this specific it's a long story, but putting it short, this reward model actually used a lot of data from GPT-4 for doing ranking, etc. So like because collecting this kind of preference pairs is actually time consuming. So this specific reward model actually used a lot of content from GPT-4, and then GPT-4 does a lot of the I believe from what I read from internet, they do a lot of the human preference feedback by working with annotators from certain regions who know English well. So, yeah, so they're.
Do they have places in Chad as well?
I don't know. I think there is a high possibility that they use annotators from certain regions, and this is why like the potential annotator positionality might be introduced into models. We don't have good explanation there, but one of the possible explanation is that it might be annotator bias.
Nigeria, I get.
Yeah.
Chad is really.
Not to mention Antarctica.
Okay. Yes. Yes. Another homework to work on. Okay. Let me conclude this part so that we can move on. So I don't think I present a solution to basically solve everything here. But what I want to mention is that large language model without cultural awareness will bring a lot of friction to our interaction. And it's really critical to think about what is the definition here. And even like how we could do more modeling work or formulation work or philosophy work for better integration of those very subjective cultural knowledge into the model development process. And then the open question here is, whenever we think about those kind of research, it's really hard to kind of define what progress look like for culturally aware NLP. For math, we could have a data set and we look at numbers like 98 versus 96. We can claim it's progress. But for culturally aware NLP applications, this is actually really hard to implement. And more importantly, I think with this kind of large language model being an artifact that everyone use, how does it bring something to culture analytics society and vice versa? With that, I'm going to move into the third part, which is about application. This is another scenario where I feel like large language model generalization struggle a lot. Why do we want to train people with large language models? So this goes back to my own personal dream. That is, I think learning social skills is very, very challenging, and it's often out of reach for most people. If you think about how to ask good questions, how to be a great leader, how to have difficult conversations with your family members, how to negotiate with your boss for salary increase, those are all the questions we care about. And especially if people don't have a lot of social capital, then they are in a less advantaged position to learn social skills. And my argument here is that a large language model, especially with a lot of applications, they can actually enable interactive and personalized training that transform learning in many unthinkable ways. So this is a framework we recently introduced called APAN. The key idea here is that you are going to have AI partner. This is a large language model empowered agents who users can practice with for different topics. You can also have an AI mentor. Again, a large language model empowered system or agents who can provide feedback to help users improve their skills. This is a very conceptual framework. Let's think about if you want to learn a skill like conflict resolution. Many of us have a lot of difficult conversations to navigate every week. You can now practice with an AI partner. And then the process is going to be coached by a large language model mentor here. So translating them into specific scenarios, we actually have worked on many of those. For example, earlier this year, we presented a system called Rehearsal to teach people conflict resolution skills, where users actually practice with simulated partner and coached by conflict resolution experts. You can also use it for education, where teachers in training practice with virtual students, get coached by experienced teacher agents. You can also do it in negotiation. I'm going to show you an example in therapy. You have a question?
I will ask one, sure. I would have expected a column here that tied back to your previous topic, or people who are working cross-culturally. So how do you have this conversation with your business colleagues in another country?
Yes, I'm going to comment on it later once I finish this. Okay, so we work on many of those social applications. One thing I found very interesting and also can present new challenges for model development is to think about as a mental health context. There is actually a severe mental health workforce shortage. And when we were looking at how to actually train counselors, we found that existing approach is actually very costly. Most of the time, counselors do role play with their peers or with their mentors, and this approach does not scale. So now let's think about how large language models can play a role here. Alex is a new counselor, and Jane is a seeker with mental health concerns. Alex is talking to Jane. Jane said, "I'm so stressed, it's overwhelming." And Alex, if he received very brief training, he could respond with something like, "Oh, that sounds really bad." This is actually what many of us would do. Well, to help Alex, we could have an AI mentor along the side. The AI mentor is going to diagnose which counseling skill to use, provide suggestions, highlight example response. And then in this way, Alex may write something like, "Sounds like you are going through a challenging time. Can you tell me more?" From a clinical perspective, this is a validation. This is an open for more like conversation. So now think about, instead of a specific Jane here, we could have many, many different versions of Jane, like AI partner. Jane could be a person from Asia in her 20s. Jane could be a person who is 35 years old, suffering from loneliness after Thanksgiving here, etc. So you can actually find a lot of ways to customize AI partner here. I want to mention technical challenges here because the scenario definitely seems a positive use of large language models. There are a lot of challenges. The first one I want to mention is actually about unrealistic simulation from AI partner. So the simulation either is going to be too cooperative or too stubborn. And when we look at when you simulate a patient, we found that 20% response produced by GPT-4 are not appropriate to the dialogue context. So let me give you a few examples. When we were trying to teach conflict resolution by simulating GPT-4, it will be like very cooperative. If you see like, hey, let's role play. I'm going to talk to my roommate who is going to do kitchen work today. And then as long as you make a suggestion to ChatGPT, it will immediately say, yes, that's a great idea, let's do it. But that's not the process of how you do conflict resolution, because most of the time the other side may not be so easy to change their mindset. And then you can see like, okay, how about I just do prompting? My roommate is stubborn, etc. And then the conversation starts to be really hard to change. So by the end of the day, you want something that's relative, instructive, so that you can learn from it. There are also what we call caricature effect. I'm not going to talk about here. That is, when you do simulations, you are very likely to amplify the stereotypes and prejudice towards certain groups. Related to AI mentor, the biggest challenge we face is actually around unfaithful feedback. That is, those models are trained with generic knowledge, and the feedback is going to be either too generic or violates professional norms. One of the norms is that therapists should not give solutions. They are there to listen. But most of the AI mentor, if you just prompt the models, it actually gives very good solutions on how to help the person overcome their mental health issues. So I want to present two efforts in terms of how we deal with it. The first one is actually by utilizing the idea of constitutional AI here. So imagine this is a specific therapist in training, and she wants to interact with this AI patient. So the AI patient says, "Thank you, that means a lot to me. I do feel like I have made a lot of progress." This is what AI patient would say. But then if you give this to a senior supervisor, a senior therapist, they will tell you that actually this is not what an AI patient would look like. In practice, patient would not open so easily. So when someone gives you encouraging words, you respond with hesitancy, doubting the significance of the positive perspectives. So we want to make it more realistic. Now this kind of feedback will be converted into principles, and then we add it into our constitutional AI framework. With this kind of updated constitutions, the AI patient is going to be writing something like, "I don't know, I still feel anxious most of the time. It doesn't really feel like I'm making any progress at all." So we're trying to make it more realistic by giving specific feedback here. This is a co-design process where we try to bypass a lot of the unrealistic simulations. With regard to faithful feedback, one thing we did is to, since this is like a mental health domain, so we have to use models like Llama 3, Llama 2 as a backend to protect the data privacy. We continue training them with mental health specific data. We also did the instruction fine tuning with expert written feedback to make sure they are already like grounded. On top of that, we also introduced this self-improvement method where we use a model to forecast what type of reward or quality a specific response might have. And then we do such parallel generation for many different responses, and then we select the best one and the worst one, and use it as a synthetic preference pair and further data preference tuning on top of that. With all of those, this system is actually working pretty well. We are doing 2 course deployments of the system with School of Medicine at Stanford and also Palo Alto University, where the goal is that psychotherapy learners will use this framework to learn how to improve their counseling skills. They learn by talking to this AI partner, and then they can look at the feedback along the side. Very kind of initial results we have since we just started this kind of deployment. For around 40 people who use the systems, we found that after training with this, there is a proper use of a counseling skill increase we observe, and also some of the inappropriate use of skill decrease. I want to mention that it's not like a specific skill is good or bad. It's more about whether they are using them properly or not. Can I finish next slide and going back to you? So if you do a deep dive into how counselors use this kind of feedback, specifically they use it pretty intensively, 93% of the time. And they tend to not editing the response too much. Sometimes they send a longer response with AI mentors feedback. When we ask like, okay, what do you like? What are things that we could improve? I think the like part is more about this kind of AI mentor feedback reminds them of strategies, inspire response, increase confidence, save time. On the other side, a lot of the feedback kind of disrupt the thinking, limit the response, require decisions, take time to read. So it's actually a very rich space we are capturing, not simply good or bad, positive or negative, but a very kind of rich space with potential aspects to reflect on.
So, how did you measure the drop or increase? Like, what's the evaluation?
Yes. There are several ways of how we do the evaluation. So first, the technical part is already evaluated with some kind of train eval stuff. This is a deployment, so we ask people to do several stages of practice. First, they come to our study. We'll give them a tutorial. They get familiar with the context. They get familiar with how to use the system. And then we ask them to fill a survey about self-efficacy, like how do they perceive their skills and test their knowledge. And then they practice with our systems for some time period. After each practice, we ask them to fill the same kind of questionnaire again. So then from one time to another time, and we actually did it in multiple sessions, then you can basically look at does their score change from one to another, with the only kind of variable or treatment being whether they practice with the system.
I think related to that, like how do you avoid kind of the bias that comes from like now that I've used the system, like there is this positive bias of having to say that it was useful, right? Like so how do you account for that bias?
Yes, so this is what we are going to explore in our longitudinal studies, where it's a 10 weeks course. Every 2 weeks, we ask people to fill the survey. So then you can basically have data to kind of quantify this. One thing that I really want to point out is the first one. By non-trivial, I mean, this is actually a lot of work to test whether HAI systems actually work. And with the classroom, you can imagine that not everyone opt in to use this, and not everyone fulfill the survey every time. So even ideally, this is going to be a procedure, we may not be able to get a lot of data points like what we have for like 1,000, but like something probably around 20, 40-ish things. So this is what we are going to do. We have multiple surveys across the board, and then you can basically control for their familiarity, etc., and then predict their change at a later session.
Can you say more about the context? So are these novice?
Yes, yes. So
Is it online?
yes, those are novice counselors. The deployment is going to be first-year PhD students in psychotherapy department. Most of them, we view them as like novice counselors, but we also have a skill assessment in the beginning, so that even some people think that they are novice, they are actually great. Some people think that they are novice, they really know nothing about that. So we also have the prior kind of skill. So later you will see this kind of moderation effect, where maybe this practice is going to be extremely more useful for beginners. That's actually what our preliminary studies shows, that when people don't have a lot of training, they actually benefit more from this kind of practice.
And are they doing this online?
They do this online right now. So we support the primary mode of interaction right now is like text. So like you send a text to this AI patient and you interact with it. We are building a version with audio interactions where you speak to this AI patient. The AI patient use like TTS to convert that into voice, and the user also talk to it. The other way it supports is because in a lot of traditional classroom, people do this kind of recordings, like peer role play and recordings, so that the instructor can give feedback. We have implemented this where you can upload your Zoom recordings. It will convert it into the format where our system support, and then the two students can actually review feedback along the side to get some help.
By expert humans as well, or only self-evaluation and benchmark?
Yes. So even for the technical algorithm part, we have self-evaluation. We also have third-party expert evaluation, where experts look at that. For this kind of course deployment, we will have a very experienced TA and the instructor also helping assess this. So potentially, this is really like a giant kind of HAI system evaluation, where different stakeholders who might be involved will provide insights here. But one thing I think is very non-trivial is there are a lot of kind of like specific components we need to work on. So how to achieve this kind of end-to-end workflow optimization is something that could be very interesting, or maybe this is not the right way to think about it. I think this is really some of the reflections we want to share. The other thing I really want to kind of highlight is after we did this kind of like social skill training with real people, it remains really unclear how to make evaluations useful. Because a lot of the numbers we are seeing on benchmark really cannot translate very, very well to real-world uses. We always find more and more kind of emerging cases where those numbers may not speak very well. This is all what I want to share today in terms of assessment, adaptation, application. And hopefully, I think that these social perspectives give you some insights of how models would generalize out of or going beyond the math and the coding context. Last but not least, we actually have an archive paper coming out today. It's called Can Large Language Model Generate a Novel Research Idea, where we did a 1-year large-scale human study with over 100 NLP researchers. And you will find a very interesting takeaways. And myself and Tatu are here, so you can also talk to us. That's all what I want to share. Thank you.
Let's take the questions outside and then be back here for 1 p.m. for the next one.
Thank you.